Hello everyone, welcome back to the another session in Principles of Programming Languages. We'll be going to cover the last topic of third unit, which is user-defined overloaded operators and coroutines. If time permits, we'll cover this coroutines, otherwise we'll make the other video, we'll see. Now, so let's start about user-defined overloaded operators. So when I say about overloaded operators, many of you can recollect the previous concepts of your subjects. So generally when overloading happens, when the two are used for the different purposes, but the two are in the same form. Fine. When I have let's take an example. Now I have an operator, I am taking plus as my operator. If plus is the only one operator to compute addition and to compute string concatenation, then purpose of doing the operation is different, but using only one operator. Now this kind of strategy will gives you overloading concept. Though the purposes are different, we were using the same kind of algorithm, we were using the same kind of operator, we were using the same kind of function. If it is operator, then we say it is operator overloading. If it is function, we'll say it is function overloading. If it is method, we'll say it is method overloading. As far as the concept concerned, we'll be going to talk about user-defined overloaded operators. Right? Now, so these are the things which were designed or defined by the user itself. We'll be going to talk about how these were supported in major languages and what is the solution to overcome of this problem. Right. Now how they overcame, that's also we'll cover in this video. Now let's look at what do you mean by user defined overloaded operator. So basically operators can be overloaded in few languages as per as the study is concerned, and those languages are Ada, C++, Python and Ruby. In these languages we'll handle the operator overloading concept. The concept is same, one is used for many purposes. How can we make the operator ensure to compute the right operand or right operation, that we'll see. Now let's take some example in Python that I wanted to add a complex number. So I am taking the function which is complex. So here the addition is also the function. In the previous video we were discussed the writing syntactical structure is different from language to language. Few languages will use keyword, some def. We were discussed in the last video. So Python uses this keyword to ensure it is a function, and these are what your parameters. Now definition, addition is a function which is having two parameters, self and second are the parameters. Now return complex, look at this self dot real. Usually complex number can be added, cannot be added something like of a plus b. You cannot add complex number as simple as your normal number, because a normal number will have only one part, but whereas complex number will have two parts to add, right? Complex number will have real part and imaginary part. Let's say that I wanted to add two complex number, complex 1 number, complex 2 number. Complex 2 number is also have two parts, real part and imaginary part. Now first complex number real part should added with the second complex real part, and first complex imaginary number should added with the complex 2 imaginary part. The same thing has to be get reflected in the function itself. Now here we were taking the explicit declaration of self. Python uses explicit declaration of self. Self is a keyword which we defined as a explicit thing to avoid operator overloading concept. Now let's see how it is doing. Now we were pointing this self and self dot real. Right? Now self dot imaginary part, second dot real, second dot imaginary, both will get added. So this is what actually explicit declaration in Python in order to overcome the operator overloading. Now let's see the other example in other programming language, without explicit declaration, I don't want to give any kind of self or something keyword, but still I wanted to make addition of some or performing some operation where user defined operator overloading should get overcome. I don't want to use any explicit. There is a programming language which is called C++. This language will not use any kind of explicit declaration. It will add two numbers or it will perform any kind of operation and will not see any kind of operator overloading concept. Now let's see. So we were discussed at this point just before in the slide, and that will once quickly finish. In most languages that support object oriented programming, a reference to the current object is implicitly sent, and this is what. So when we are using object oriented, I am giving the example of C++ as I cannot give all the object oriented languages for the example purpose. I can give the example of Ada, Java, and these languages comes under object oriented. But I am taking the sample example of C++ because object oriented languages will take a reference to the current object is implicitly sent with each method call. We'll take one reference object. Let's say the reference object is what? Second. Now we'll use this reference object and we'll perform the operation. In Python we'll not do the same. Whatever we were discussed just before, that's the case of Python. In Python, this reference must be sent explicitly. That's the reason why we do have self as a keyword. It is an explicit declaration to ensure to put into the each and every operation. And that is the reason why self is the first parameter to our method add. Now the example of add method could be written for a complex class in C++ as complex is a class. Operator plus is a user defined operator and it's have a parameter which is second, right? Now look at how the computation was done. Real plus second dot real, imaginary plus second dot imaginary. We do not referring to this real with the help of second. With the help of any other different reference variable, it itself take a reference variable which is second. That's what it is implicit. We do not have any kind of explicit. So, and this is what user defined overloaded operators. Now, there is one more concept which is closure. Closure and coroutine, these two or people think that are same. No, these having a difference, that also we'll see. Before we see about differences, let's consider what do you mean by the closure and what are the relations with the subprogram and coroutine. Now let's see that. So generally closure is a subprogram. Closure is a subprogram. Then we already have a subprogram. What is the special uniqueness of this closure? That we'll see. It is a subprogram. And this subprogram is created in one referencing environment, or else we define the closure in referencing environment, and the calling procedure of that can be from any arbitrary place. So that is what the closure. And the referencing environment is needed to the subprogram can be called from any arbitrary place. Now, closures are having restrictions. As subprogram can be created in anywhere of program, you cannot define the closure in everywhere, right? So you can find subprograms in nesting classes, in nesting subprogram, and the languages which not support nesting subprogram, there also will use subprograms, correct? The languages, if they support subprogram, will write subprogram. The languages will not support, will support nesting subprogram, there also will find subprogram. But closure is not that. Though closure is a subprogram, closure is a special area where we'll write, and that special consideration is what? Closures can be defined only in the languages where the language support nesting classes or nesting subprograms. There only you can create. So C doesn't support nesting, right? Nesting classes or nesting subprograms C doesn't support. Hence, closure cannot be applicable in C-based languages. JavaScript allows nesting subprograms. Hence, closure can be used there. That's it. So there is a point to ensure the same. If a static scoped programming language does not allow nested subprograms, closures are not useful. And so such languages do not support closures. All of the variables, when I said it is all, it comes local and global variables in the referencing environment of a subprogram in such a language are accessible. We will see an example how it will be accessible. So before we see about, there is one point. A variable whose lifetime is that of the whole program is said to have unlimited extent. That means global variable. We were talking about global variable. This usually means they must be heap dynamic or stack dynamic. When I say a variable belongs to global variable, so that time period or lifetime of that variable in the program, naturally it will be throughout the program, that we say about unlimited extent. And the memory allocation of this kind variable will be maybe of heap dynamic if we were using a pointer. If it is not, it will be a stack dynamic. Right? Now, we will see an example how closures are used. So, I am taking the example of JavaScript here. I am taking the example of JavaScript. Why only JavaScript? Because JavaScript is the language which support nesting subprograms. Why nesting subprogram is prerequisite for this? Because closure cannot apply it without nesting subprograms. That's what we were choose to take only JavaScript. Now, let's see here JavaScript code. Here, this is what I can call with the name of closure. What I said, closure is a subprogram. Yes, it is a subprogram, and closure is defined in one referencing environment. Yes, it is defined in one referencing environment, and the calling procedure of the closure can be done in any arbitrary place. So, I am calling from here. Now, look at the way of executing the closure is little bit different. That is what we were printing some HTML document over here. On the HTML document, the printing line is what? Whichever we given in the double quotes, that will come as it is. And this after colon, we expected some result to be done. And this area will be filled with the result. Now, let's say that is, we'll see on the output screen, add 10 to 20, and this result is expected from this function call. And what this function call will do, add 10 of 20. Now, let's say the function which is make adder, the value is passing as 10, will enter inside of this, and there inside we do have some computation which is written x plus y. X value will come from 10. So, that's of x is 10, and y value is what? Function y. It is as same as your closure, which is 20. So, 10 plus 20 will become, which is 30. And the next is about the next one, add 5 to 20. 5 is the first parameter, 20 is the second parameter. Addition function will operate, 5 plus 20 is of 25. Now, on HTML screen as an output part, we will see about add 5 to 20 is 25. So, this kind of calling procedures will called as subprogram, which is closure. Closure is what your one of the subprogram. The restrictions, you cannot see these kind of things in your subprograms, right? What the way we will be defining subprogram is, we will be taking the subprogram not particularly this way. You cannot write this type of function calling or subprogram calling procedure in any of the language. It is what the uniqueness of your closure. We basically do closures in this way. We will define closure in one specific environment with the computations and all. The calling procedure basically is something like this. Even this is allowed. If you don't want to give like a closure, you are also allowed to give add x of y, and x comma y values you can use from alert box to enter. Anything is possible in the closure. So, this is what actually about the closure. So, in the next video, we will be sorting out the differences in between what is closure and what is coroutine. Even coroutine also will cover in the next video. Right. Thank you all.